plots are they're fairly easy to deal with. Okay, so let's fill in some of these blanks here. A scatter plot is a graph that shows relationships between two sets of data. Okay, so we talked about that when we talked about definitions of graphs and types of graphs, and we're trying to pick out what type of graph you would use. So on the screen here are two examples of scatter plots. Okay, notice that scatter plots are really scattered dots on a graph. Okay, the first one shows television size and price. Which, what can you tell me about the price and size of a television? What tends to happen? As the size gets bigger, the price gets bigger, right? Would you agree? So as the size goes up, the price also goes up. But as the size goes down, the price goes down, typically. Now, can we have a big TV that costs less than a smaller one? Absolutely, that can happen, right? It can be on sale. That's why this one right here, the 65-inch TV, is cheaper than the 55-inch TV, but maybe it was on sale. Okay, but in general, we can say as the price goes up, or as the size goes up, the price goes up. Okay, and then we have this one, scatter plot, kind of dots all over, and they look pretty random. The first one, you could see they were kind of going up together. This one, they're pretty random, because a person's age does not really affect how many pets they own. Would you agree with that? We could have somebody that's 70 years old and never had a pet. Okay? And maybe some of you in here have never had a pet. It's just your family just doesn't really want to have that to take care of. And some of you maybe have 10 pets. Okay? So that one is very scattered. It's all over the place. All right. So the next one is, to fill in these blanks, the line of best fit. Okay, the line of best fit is the line that comes closest to all the points on the scatter dot plot. On a scatter plot, we don't ever connect the dots. Okay, instead, if we're going to draw a line, we draw what's called a line of best fit. And that just means we're going to put a line in between the dots, so there's about equally as many dots above the line as there is below the line. So if I was going to draw a line of best fit on this graph, it would look something like that. Okay, I want you to draw in that line. Okay, and notice how there's about 4 or 5 dots above the line, there's about 4 or 5 dots below the line, there's a couple dots on the line. Okay, it shows the general trend of the data. You can see that in general, it's going down. Okay, in the second one, in general, what's happening? It's going up. So if we draw a line of best fit on this graph, it's going to look about like that. Okay, the whole purpose of a line of best fit is to help us make predictions. Okay, that line of best fit will help us make a prediction. So if this first one was talking, or the second one here, maybe was the size of TVs, and we said a 40-inch TV would cost about $42, or maybe it's hundreds of dollars, $4,200, I hope not. And that's really expensive. But we could then make predictions based on that graph. Okay? All right, let's look at the next part. The next part talks about correlations. When we have scatter plots, we're going to use what are called positive correlations. And it's either a positive correlation, a negative correlation, or there's no correlation. Okay, and that just means relationship. Correlation means relationship. Okay, so the first one, what do you notice about all these dots? They're kind of going up. right? If I drew a line of best fit, they're heading up. So what we're going to write on these blanks is that as x increases, y also increases. This is a positive correlation. Okay, as one thing goes up, the other also goes up. Now, it could be the exact opposite. As one goes down, the other goes down. But they have to be going in the same direction, either both up or both down, and then it's positive. Okay, the second graph, you will notice that it seems to be going down. Okay, and that means as x increases, y decreases. Okay, we would call that a negative correlation. And then the third one, there are just dots all over the place. There is no relationship in that data, so it's no correlation. Okay, so what are some examples of this? Let's see, positive correlation. The height of people and their weight is a positive correlation. Okay, as people get taller, what happens to their weight? It gets higher, right? As you get taller, your weight goes up. If you're shorter, your weight is less. So that would be an example of positive correlation. Okay, an example of negative correlation. Candy bars. Like the size of candy bars and the number I can eat. Do you agree with that? If you have the little bite-size candy bars, how many of those can you eat at one time? Way too many, right? They're just like little tiny bits of chocolate. You just keep eating them. As the candy bar gets bigger, okay, you go from the bite-size one to the fun-size candy bar. You probably don't eat quite as many. You go to a full-size candy bar, you only eat one, right? King-size candy bar, definitely only. You get those jumbo candy bars, you don't even eat the whole thing. Right? So as the size of the candy bar gets larger, how many candy bars can you eat at one time? It goes down. So they're going in opposite directions. One is going up and one is going down. Okay, and then no correlation, that would be like your shoe size and your bowling score. Does your shoe size affect how you bowl? Not unless you have clown feet, right? But probably not. So it doesn't matter what size shoes you wear, your bowling score may be all over the place. Okay, so that has no correlation between those things. Okay, so let's look at this one. Use the given data to make a scatter plot of the weight and height of each member of a basketball team. Okay, so we have our height and our weight. We're going to say height is our x value, weight is our y value. So we need to label our graph. Okay, grab your pencil and do this. We're going to put height on the bottom. And weight over here on the side. Okay, the corner of the graph is always 0. Now, I'm going to make this a little bit misleading, right? We talked about misleading graphs and kind of leaving out a chunk of the graph. I'm going to do that, but I'm going to let people know that I'm doing that. So I'm going to do this. I'm going to put a zigzag on the line there. And that just really means there's a break in the graph. I'm going to skip a whole bunch of numbers. Because when I look at the heights, it goes from 68 being the lowest to 74. I don't want a number 0 through 74. Okay? So I'm going to skip a whole bunch, 0, and then I'm going to go 68, 69, 70, 71, 72, 73, 74. Okay, we have to number in order, from least to greatest. So I numbered the height. For weight, what should I count by? Tens, maybe? That would make sense, right? Should I start at 0 and count to the top? No, I'm going to skip a whole bunch too. What should I start at? What's the lowest weight? 160. So let's go 160, 170, 180, 190, 200. Okay, when we make a graph, we have to label everything. Now we're going to plot our points. So we're going to start with this first one. The first basketball player was 71 inches tall. So I'm going to go to 71, and he's 170 pounds. Put a dot there. So 71 and 170. The second basketball player, 68, and he's 160. Put a dot there. The third one is 70, 175. And then 73, 180. And finally 74, 190. Okay, we do not connect the dots. This is a scatter plot. So we have scattered dots. It says, what type of correlation is shown in the graph? What would you say? Is this positive correlation, negative correlation, or no correlation? What do you think, Brooklyn? Huh? Yeah, as the height of the basketball players goes up, their weight also increases in general, right? So it is positive. Okay, what if I asked you to make a prediction? Let's say somebody on the basketball team was 72 inches tall. There was somebody that was 72 inches tall. Do you think you could tell me how much they weigh, approximately? And I'm guessing it would help if we drew a line of best fit. If I put this line in here, if somebody is 72 inches tall, about how much would they weigh? Really? Right around 180. Would you agree with that? 72 inches is right here. If I follow it up, it's right in here, which is right around 180. 175, 180, somewhere in there. Okay, that would seem to make sense. What if somebody was 69 inches tall? About how much would they weigh? Somebody that's 69 inches tall would weigh what? Exactly. About 165. What if somebody was 200 pounds? How tall would they be? What would you say? Keela? 75. Maybe 75, 76 maybe. I would say this line is going to come out about right here, so this would be 75, maybe 76 inches tall, somewhere in there. Okay? Does that make sense to everyone? Okay. Flip the page. Okay, so you're going to have to be able to do that on your homework. Make some predictions, look at a graph, tell if it's positive, negative, or no correlation. And then you're going to have to be able to do this. Okay, and we're going to take these one at a time. It says, do the data sets have positive, negative, or no correlation? So you don't have to do any graphing. You just have to decide, is it positive, negative, or no correlation? Okay, the size of a jar of baby food and the number of jars a baby will eat. Okay, so let's think about that. If the baby food jar was like the size of a thimble, like super little like this, okay, at home, you're talking about this little tiny jar of baby food. How many jars of baby food do you think the baby could eat if that was the size? Friendly. Okay, a lot, right? We don't know for sure, but if it was that big, a lot. So a small jar means they eat a lot. As the jar gets bigger, okay, now we go to a baby food jar that's maybe this size. Are they going to be able to eat a lot? But they can maybe eat, I don't know, throughout the day, maybe a couple. Okay, and if we keep getting bigger and bigger and bigger, and now we've got a jar that's the size of like those huge mayonnaise containers. If a baby can eat all of that, that's a fat baby, right? That's a chunky baby. Okay, so as the jar size increases, what happens to the amount the baby can eat? It went down. When they go in opposite directions, is that positive, negative, or no correlation? Really? Negative. So we would say this is negative correlation. So write that down. We would say it's negative. One goes up, the other goes down, that's negative. Okay, how about this one? Letter B, the speed of a runner and the number of races she wins. Okay, so let's start with the speed of a runner. If your speed gets faster, if it goes up, what happens to the number of races you'll win? Most likely. Kason. It's going to go up, right? So if you get faster, the races you win goes up, and if they're both going up, what kind of correlation is that, Tyler? Positive. What if you get slower? If you get slower, the number of races you win also goes down. So it's still positive, right? Because they're both going in the same direction. If they're both going up or they're both going down, it's still positive. It's negative when they go in opposite directions. Okay, let's try letter C. The size of a person and the number of fingers he has. So when I start as a baby and I start growing, I'm getting bigger and bigger and bigger and bigger. What happens to the number of fingers I have? They stay the same, right? I'm glad that as I get bigger, my number of fingers doesn't keep growing. That would be weird. So is this positive, negative, or no correlation? No correlation, right? Your size has nothing to do with the number of fingers you have. So no correlation. Okay, so letter C was no correlation. How about letter D? The population of a state and the number of representatives it has. Making you remember some things from social class. What do you think? Caleb? Okay. So as the population increases, the number of representatives also increases. So what is that? Positive. Let me change this a little bit. The population of a state and the number of senators. What would that mean? The population of a state and the number of senators. What do you think? How many senators does every state get? 2. Does it matter what our population is? No, you still get 2. So tell me about the correlation between the population of your state and the senators. Is there one? As your population rises, do you get more senators? As it rises, do you get less? No. So there's no correlation between population and the number of senators. Okay. How about this one? The temperature outside and the number of people at a pool. It's an outdoor pool. What do you think? Caleb? Okay, right? As the temperature increases, there's probably going to be more people there. But if the temperature decreases, there's going to be less people there. So they're going in the same direction. They're both going down or they're both going up. So what type of correlation is that? Positive. They're both going in the same direction. Both up or both down, then it is positive. Because we know you can always have that one crazy person where it's 50 degrees outside and they want to go to the pool. Right? We have those crazy people that jump in the lake this time of year. You did that?
Well, I took my horse swimming yesterday.
Or,
Yeah, it was cold.
yeah, I bet. See, I'm not willing to go in the lake yet this time of
I
year.
will. Big word.
Did anybody else jump in the lake yet this year? I mean, my child would, but I would not. No? Fur. Okay, how about this one? The length of a movie and the number of times it can be shown in a day. What do you think? Positive, negative, or no correlation? Friendly.
Negative.
Negative. Can you explain that?
Because the longer the movie is, the less times they can show it in a day.
Right. So, thinking about that, if the movie was 1 hour long, right, it could be shown 24 times. Everybody agree? If it was a 2-hour movie, well, now it can only be shown 12 times. If it was a 3-hour movie, now it can be shown 8 times in the day. If it was a 4-hour movie, it could be shown 6 times. So as the hours are increasing, the number of times it can be shown is going down. They're going in opposite directions, so it is negative. Okay, a person's height and their birthday, like the day they're born. A person's height and their birthday. What do you think? Really? No correlation. So if you're born on May 3rd, you're going to be short. But if you're born on May 4th, you're going to be tall. No, it doesn't work like that. It has more to do with genetics. So there's no correlation there. Okay, last one. Describe the type of correlation you would expect between the number of absences in a class and the grades in a class. What do you think? What happens to your grade if you're gone from school a lot? It probably is going to drop, right? If you miss class a lot, your grade tends to go down. So if there are more and more absences, the grades are going to go down. What type of correlation is that? They're going in opposite directions. Negative. Can you think of your own example of a positive correlation? Maybe think of something that would be 2 things that would have a positive relationship. Or at home, if you can think of something, type it in the chat. Anything that has a positive relationship. Can you think of any? How about the amount of time you spend studying in your grade? Would that be a positive correlation? In general, if you spend more time studying, what's going to happen to your grade? It's probably going to go up, right? Would everybody agree with that? And if you spend less time studying, it's going to go down. So they're going in the same direction, so that's a positive correlation. Okay, somebody said the size of a cereal box and its price. Would you agree? As the cereal box gets bigger, it probably costs more. Okay? How about a negative correlation? Can you think of one that's negative? We could use a cereal box. The size of a cereal box and what? The amount you can eat in one sitting, maybe, right? If you have the little individual size cereal box, eat the whole thing. As the size gets bigger, you eat less of the box. Okay, anything that has no correlation. the temperature outside and your grade in math class. Is there a correlation between the temperature and your grade? No. Maybe you're doing school outside and you do better. But in general, no. Golf shoe size and your golf score. No correlation there. Okay? So we